Here's a problem that confuses almost everyone. Find 4 terms of the square root of 1 plus 2x minus 2x squared. But wait, how can a square root give you x cubed? Doesn't that feel wrong? To understand this, we need to talk about one of the most powerful ideas in mathematics: the Taylor series. Here's the big idea. Any messy function can be rewritten as a simple polynomial, an infinite sum of powers of x. Think about the square root of 2. It equals 1.41421 and so on forever. Each new decimal digit makes the answer more precise. A Taylor series does the exact same thing, but with powers of x instead of decimal places. Each new term is a correction that gets you closer to the true answer. So when we write square root of 1 plus 2x minus 2x squared equals 1 plus x minus 3 halves x squared plus 3 halves x cubed, we are saying this polynomial on the right is an approximation of the square root on the left. And here is the beautiful test. If we square our answer, 1 plus x minus 3 halves x squared plus 3 halves x cubed, all squared, we should get back 1 plus 2x minus 2x squared. And it does. The higher order terms vanish. That is how you know the expansion is correct. Now let us actually find these terms using the long division method for square roots. Step 1. The square root of the first term. Square root of 1 is 1. That is our first term. Step 2. Our divisor starts as 2 times the first term, which is 2. Divide the next part, 2x, by 2. That gives us plus x. So our second term is x. Now the complete divisor becomes 2 plus x. Multiply that by x. We get 2x plus x squared. Subtract this from what we had. The remainder is negative 3x squared. Step 3. The new divisor is 2 times our answer so far. 2 times 1 plus x, which is 2 plus 2x. Divide negative 3x squared by 2. That gives us minus 3 halves x squared, our third term. Step 4. We continue the same process. The next remainder gives us plus 3 halves x cubed. And now you see why x cubed appears. It is not the square root giving us a cube. It is the series expansion adding corrections term by term. So remember, the square root of a polynomial is a Taylor series. Each term corrects the approximation. Our answer? 1 plus x minus 3 halves x squared plus 3 halves x cubed. Square it and you get back the original. That is the beauty of series expansions. Follow for more deep math explanations.